So now we're going to start section 14.6, which is about triple integrals. And so we're going to start this section similar to how we started double integrals. We're going to talk about iterated integrals first. So let's suppose that f is continuous on a solid region Q defined by x is between a and b, y is between h1 of x, h2 of x, and z is bounded between functions of x and y, g1 of xy, g2 of xy, where h1, h2, g1, and g2 are continuous functions. Then we can evaluate this triple integral over the solid region Q of this function here as this iterated integral from a to b, h1 of x, h2 of x, g1 to g2 of our function f of x, y, z is dz, dy, dx. So again, this tells us how to evaluate iterated integrals here. So let's look at an example. Evaluate the triple iterated integral 0 to 2, 0 to x, 0 to x plus y, e to the x, y plus 2z, dz, dy, dx. All right, so let's start off our integral here. 0 to 2, 0 to x, 0 to x plus y. And it's dz, dy, dx. So we're going to start by integrating with respect to z. Now this e to the x, there's no z there, so that's constant. So this is the integral from 0 to 2, 0 to x, and then we get e to the x. The integral of y will be yz. The integral of 2z is z squared from 0 to x plus y, dy dx. So now we're going to get 0 to 2, 0 to x. Plug in your top bound and your bottom bound for z, and you'll be left with e to the x. And then if I plug in, you'll get y times x plus y plus x plus y squared. Oh. Dy dx. So if you foil this part here, and if you distribute this part here, you're going to get the integral from 0 to 2, 0 to x, e to the x, it'll be x squared plus 3xy plus 2y squared dy dx. So now I'm going to integrate with respect to y now. So this e to the x, there's no y there, so that is constant. So we're getting the integral from 0 to 2 e to the x. Now integrate again with respect to y. You'll get x squared y plus 3xy squared over 2 plus 2y cubed over 3 from 0 to x. So replace y with x and y with 0. So you'll get x cubed plus 3x cubed over 2 plus 2x cubed over 3. And if you get a common denominator for these fractions, it would be a 6. So you're getting 19 over 6 if you add them all together, 0 to 2, x cubed e to the x. Now, for this integral right here, you're going to need to use integration by parts, and you're going to need to use it 3 times. All right, so if you use integration by parts here, you're going to get e to the x will appear in all of the terms. So I'm going to factor it out. It'll be x cubed minus 3x squared plus 6x minus 6. And plug in top number minus bottom number. You'll get 19 e squared over 3 plus 1. And that is my answer for this iterated integral.